Eliminate the parameter and use the rectangular equation to sketch the plane curve. We have x equals 3 sine of t, y equals 3 cosine of t, and t, we're only pick values of t from 0 to 2 pi. All right, so there's a couple ways we can sketch this, right? Now you notice it says to eliminate the parameter, okay? So we'll do that here in a little bit. But one thing we could do is, if you don't want to eliminate the parameters, you can always make a table of values, right? So we'll get t, x, and y, okay? We'll just make a table here, plug in values of t, right? So, okay, I'm going to pick values of t that are between 0 and 2 pi. So maybe I'll pick 0, pi over 6, right? Maybe pi over 3, pi over 2, so on and so forth, right? And then I can get my ordered pairs, and then I can sort of plot the points and see what the graph looks like. Okay, that's one option. I'm actually not going to fill this out, right? So what does it mean to eliminate the parameter? Well, we see here that there are 3 variables, right? You got x and y, which is good, right? We want the equation just to be in terms of x and y. But there's also a t, okay? So how do we eliminate the t? Okay, well, in this particular example, we notice that we see the sine and the cosine, right? We know that sine squared of t plus cosine squared of t is equal to 1, okay? So for this, that's what we're going to do, okay? So let's just go ahead and, I guess, now we know, right? We know that x is equal to 3 sine of t and y is equal to 3 cosine of t, right? So let's square these, right? Now, remember, we can square both sides, which is legal, I guess we'll call it, right? So we'll square both sides, so we get x squared is equal to 9 sine squared of t. And then similarly, here we get y squared is equal to 9 cosine squared of t. So when we solve this, we get, okay, sine squared of t is x squared over 9, and cosine squared of t is y squared over 9. And then we can actually plug these guys, okay, into the original equation for sine squared and for cosine squared. So remember, we're actually doing 3 things here, right? We're using this Pythagorean identity. Remember, this was not given, right? But we know, no matter what, sine squared of t plus cosine squared of t is equal to 1. So we're going to sort of do some algebra, isolate these guys, get the original parametric equation in terms of x squared and y squared, okay? Or, I'm sorry, in this case, sine squared and cosine squared, and plug these guys in. Okay, let's take a look what happens. Well, I know that sine squared of t is x squared over 9. Okay. Cosine squared of t is y squared over 9, and we know that that should equal 1. So when we multiply everything by 9 here, right, we'll multiply everything by 9. This cancels out. This cancels out. That just equals x squared plus y squared equals 9. Okay. This is called the rectangular equation. Now, you can try to go ahead and solve this for y if you want, okay, but this is actually an equation that we should know, right? What is this the equation of? Okay, x squared plus y squared is equal to 9. Well, this is just the equation of a circle. It's the circle whose center is at 0, 0, and whose radius is 3. Okay, so that's, well, pretty easy to draw, right? We just, on our xy plane, right, we just plot a circle whose center is at the origin, right? It's at 0, 0, and the radius is 3, right? So we're going to go 3 all directions and just draw our circle like that. And there you go, right? There is our graph. So maybe you're thinking, well, wait a minute, could I have gotten the same graph by plotting points? And the answer is yes, right? Maybe it would not have, maybe take a little bit longer, okay? But yes, we should still get the same graph here.